Hey guys, it's Miss Johnson, and I'm here to bring you the second part of Chapter 9.3 notes today. We're going to finish out our conversation about doing a significance test for a difference in population proportions. All right, so let's just look at how we would put this all together. We're going to do one of these beasts because they are kind of long, lengthy. We're going to do one from start to finish. So just a reminder, it says the two sample Z test for the difference between two proportions. Suppose the conditions are met. That's important. To test the hypothesis that the difference between the two is 0, first we need to find the pooled proportion, p hat, of the successes in both samples combined. Then we do the test statistic. So the test statistic is where we take the difference in p hat 1 minus p hat 2, but in the denominator we're using that pooled proportion for our standard deviation divided by sample size 1 and sample size 2. Find the p-value by calculating the probability of getting a z statistic this larger in the direction specified by the alternative hypothesis HA in a normal standard normal distribution. All right, so here's our example that we're going to go through today. Again, we're going to do this start to finish. So it says high levels of cholesterol in the blood are associated with a higher risk of a heart attack. Will using a drug to lower blood cholesterol reduce heart attacks? The Helsinki Heart Study recruited middle-aged men with high cholesterol but no history of other serious medical problems to investigate this question. The volunteer subjects were assigned at random to one of two treatments, okay? So one thing I do want to point out is they recruited middle-aged men with high cholesterol but no history of other serious medical problems. This is where we need to specify in our conclusion where we have people like these. Okay, we are only testing for a population of men who have similar characteristics. Okay, so that's important to know. So 2,051 men took the drug gemfibrozil, I'm probably saying that really wrong, to reduce their cholesterol levels, and a control group of 2,030 men took the placebo. During the next 5 years, this is an extended study, during the next 5 years, 56 men on the gemfibrozil group and 84 men in the placebo group had heart attacks. So, here's the question. Do the results of this study give convincing evidence at the alpha 0.01 significance level that the drug is effective in preventing heart attacks? Okay, the second part of that is going to be interpret the p-value, which is not a super hard thing to do, but it is a point to talk about because you don't always interpret the p-value when you do the state, plan, do, conclude. That's a separate piece. Sometimes you're asked to interpret what that p-value means. Okay, so here we go. I'm going to start off with the state. We're going to state what we are doing here. We want to test our H sub O being P. Now here's the thing. I'm going to use the drug names where you've got the gembrofazil, I don't know how to say that, gemfibrozil, sorry, I don't know how to say that, minus the control equaling 0. Instead of doing P1 and P2, you could call them P1 and P2, but in my mind, I'm gonna be able to keep them easier if I know that the G is the drug, the one with the drug. So then HA, we wanna know is the PG minus PC less than 0. So this is not going to be a two-sided test. This is going to be a less than. We want to know that gemfibrozil is effective in preventing the heart attacks. So we want to know that the heart attacks on gemfibrozil are less than the heart attacks on the control group, okay? And now I need to define my, and you can put it up here too. We want to test at the alpha equals 0.01 level, and then state your null and hypotheses. But I also need to define my parameters. So PG, where PG is the true proportion of heart attack rate of heart attacks in men like these on gemfibrozil, and PC is the true proportion of heart attacks in men like these, like that's supposed to be an L, on the placebo. Okay, so here are the 4 points that are going to be important. Your 4 things that you are going to be looked for. You need the alpha level, you need the null and alternative, you need the population parameters, okay? So you've got your alpha level, you've got your test hypothesis, and you've got your population parameters, which in a 2 sample test, you need 2 population parameters listed. All right, so those 4 points have to be in your state. All right, let's move on. Let's do the plan. Okay, so in the plan, the first thing I'm going to do is I'm going to list the test. We're doing a 2 sample Z test for P. And now let's check our conditions. Random subjects were randomly assigned to treatment or control. And that was stated in the question. It says in a control group. Oh, they just shortened the question a little bit. It was stated at the beginning in the question. So now let's talk about the 10%. So here's the thing about the 10% condition. In an experiment, all subjects were assigned to treatment. I'm going to say that again. In an experiment, all subjects were assigned to a treatment. So we do not have to address the 10% condition here because all subjects were used. So I might say something like that. All subjects assigned to treatment. So I'm not worried about making sure that it's less than the population because I used all of the subjects in the study. Okay, now let's talk about the large counts. We do have to address large counts. So for large counts, so the first thing I have to do with large counts is I have to find that pooled proportion. So my pooled proportion is going to look like this. My p hat is going to look like the successes, if you can call it that, of men who had heart attacks, which it was 56 from one population and 84 from the, or 56 from one group and 84 from the other group. And then the ends, so 2051 and 2030. So that gives me 140 out of 4,081, which is 0.0343. And that's what I use for my large counts. So that's going to be important for us here. So we've got N1 times P hat being 2051 times 0.0343, which when I multiply that, it gives me 70.36. Then I have N1 times 1 minus P hat, 2051 times 1 minus 0.0343. So that gives me 1,980.6. Then I have N2 times P hat, which is the 2030 times 0.0343. And that gives me 69.64. And then I have N2 times 1 minus P hat, which is 2030 times 1 minus 0.0343, which is a large number, 1,960. Okay, all of those things are greater than 10. So check, actually, and I can probably fit that in there. Somehow state that they're all greater than or equal to 10. Greater than or equal to 10, greater than or equal to 10, greater than or equal to 10, and we are good. Okay, now let's move into the do. So I did the state, I did the plan. Now I have to do the do part. So for do, I'm going to find my individual proportions. There's 3 proportions that I need. So P hat for the G group is 56 out of 2051, which gives me 0.027. And then the P hat for the control group is 84 out of 2030, which gives me 0.0414. Okay, we already looked at the pooled proportion, but I'm just going to list it again. You wouldn't necessarily have to show this work twice. I'm just putting it so that we have it on this slide because it was on the last slide. That was 140 out of 4,081, which gave me 0.0343. Okay, there's our pooled proportion. Here's our Z, test statistic. Looks like, here's why I needed these two. I need P hat G minus P hat C, so 0.0273 minus 0.0414. Technically minus 0, okay? That is all divided by, now you use your pooled, 0.0343 times 1 minus 0.0343 divided by the 2051 plus 0.0343 times 1 minus 0.0343 divided by the 2030. Type all that into your calculator. Now, here's where if you want to use your calculator to your advantage and you want to put it in that stat, go over to tests, do 2 sample Z test. For me, it's option 3. And then put all of your, 2 sample stat tests, 2 sample proportion, that's what it is, 2 proportion Z tests, sorry, it's option 6. Okay, so then I've got 56 for my successes in the first one, 2051 for my N, 84 for my successes in the second, 2030 for my N, and I'm looking at the less than option instead of P, so I want P hat to be less than P hat 2, I want P1 to be less than P2. So I get a Z here of negative 2.47. So sometimes it's easier to go through and put that data into the 2 proportion Z test in your calculator rather than type it all in. But either way, you're going to get the same Z value. So there's your Z star, there's your test statistic. And then I'm looking at a P value of where Z is less than or equal to negative 2.47. And I get 0.0068 for my p-value. So here's what you need. There's a lot of points in this do part. You need the p hat G, you need the p hat C, you need the pulled p hat. Then you need the Z, you show the work, you list what the Z value is. Then you need the p value, you list what the p value is. Whole lot of points in the do section. And if you miss any one of those, it knocks you down to a P. There's so many points in these types of questions. All right, now I'm at conclude. So what does that mean? Conclude. Okay, so let's look at our little measuring stick. My measuring stick looks like this. Here's my alpha equaling 0.01. I had too many zeros there. 0.01. Here's my p-value. Way down here. 0.0068. Okay, we reject. Okay, we reject HO. So what does that mean for us? So we could say something along the lines of based on a p-value of 0.0068, we, and then, which is less than alpha equaling 0.01, we reject the null, H sub O being PG minus PC is equal to 0. There's statement number 1. Then statement number 2, put it in context. We have convincing evidence. We have convincing evidence that the true proportion of men who have heart attacks on the drug name, I can never spell it, GEMFIBROZIL, is less than the proportion of men who have heart attacks on the placebo. Ooh, there it is, conclude. So state, plan, do, conclude. There's my 4 pieces. There are a lot of points to hit in each individual piece, and all 4 pieces are needed just to perform these confidence intervals or significance tests. In this case, significance test. Now, when you're looking at a 2-sample test, there's just a lot more involved. That's really what it comes down to. There's a lot more involved in a 2-sample test. But you still have to have all 4 parts, the state, plan, do, conclude. Okay, now let's actually look at part B. I'm going to go to the next slide here. So in part B, interpret the p-value. What does that mean? So here's what our p-value means. If we assume that HO is true, that the null, that's an important statement to make. If we assume that HO is true, then there is a 0.0068 probability that PG minus PC is equal to negative 0.0141 or less due to random assignment alone. So basically what we're saying is that's the probability that we get, let me change colors here. This is the probability that you get this difference, assuming that the 2 are not the same, assuming that HO is true. If HO or the 2 are the same, the 2 are the same. This is your probability of getting this result, assuming that the 2 are the same. Since that probability is so low, that's why we have enough evidence to reject that null and say in favor of the alternative and say, nope, we don't think they're the same. Okay, so it's an interesting interpretation, but you have to assume the null is true, state the probability, which is your p-value, and talk about the sampling result due to random assignment alone. talk about the sampling result. And in this case, the sampling result of PG minus PC was negative 0.0141. All right, that takes us to the end. That's the end of our lesson for chapter 9.3. 2-sample z-test for P is what we were doing there. 2-sample z-test for P1 minus P2. Thanks for tuning in, and I will catch you next time.